Okay, example one, we're going to write the standard equation of an ellipse. Both sides at 0, 1 and at 4, 1. Major axis has length of 6. Some background information though, first of all, on ellipses is that, well, let's just come here. If I were to graph this at 0, 1 and 4, 1, these are the foci. And the foci lay on the major axis, so the major axis goes this way. And so therefore, since the major axis is horizontal, it matches this one with the major axis being horizontal. Therefore, I'm going to use the form of the equation x minus h squared over a squared plus y minus k squared over b squared equals 1. A just essentially means the distance from the center to the outside. Okay, so A is going to be half the major axis. So A is going to be 3 squared, or A is going to be 3, so it's 3 squared. To find H and Y, since these are the foci, the distance, or the center, is going to be halfway between the two foci. So to do that, I go with the midpoint formula of 0 plus 4 divided by 2. So add the x's, divided by 2. Add the y's, divide them by 2. 0 plus 4 is 4, divided by 2 is 2. 1 plus 1 is 2, divided by 2 is 1. So the center is going to be at 2 comma 1. And so that's going to be x minus 2 quantity squared, y minus 1 quantity squared. And the last thing we have to find is b. Okay, so if I go down here to this little diagram that I have, A is the distance from the center to the outside. B is the distance from the center to the outside in the shorter direction. And C is the distance from the center to the vertex. And A, B, and C are related with this equation, a squared equals b squared plus c squared. And so what I'm going to do is I am going to find C. And C is this distance from the center to the... So to find C is going to be the square root of, I'm going to use distance formula. This is my center point. So 2 minus, to the outer focus, 4 squared, plus from the center, 1 minus to the y of 1 squared. So it's going to be the square root of negative 2 squared is 4, then that's 0, and so C is going to be 2. Now I'm going to put it into this formula where a squared, which is 3 squared or 9, equals b squared I'm looking for. C squared is 2, so I add squared to make 4. That makes b squared equal to 5. And if b squared is 5, I'll put 5 right here. Erase 3 squared, make that a 9. And there is the standard form of the equation for that ellipse. Okay? I want you to try and kind of go along the same theory here and do number 31. Okay? To get you started, first thing I'd probably do is just graph the foci 0, 0, and 0, 8. And so I know the ellipse looks something like this. And so what that does is it puts your, under x minus h quantity squared, that puts b squared because on the minor axis is this way. And the major axis, the one this way that is 36 units long, goes underneath the y because it's longer up and down. See if you can finish it from there. Press pause and come back, see if you got it right. Alright, so according to the last thing, we said the major axis is a total of 36, and that means so A is equal to 18. So that means I'm going to put A squared with 18 squared, which I believe is 324, right there. Alright. Now I have to find the center. The center is going to be the midpoint of these two things. The x, since both the x's are 0, it's going to be 0 comma something. For the y, it's going to be 0 plus 8 divided by 2, which is 0 comma 4. So that gives me x minus 0 squared there, y minus 4 squared there. Now I'm going to have to find b. So b is this distance. Remember, we're going to find, first thing we're going to do is we're going to find the length of C and C is from here to here. Well, if C, the center, is 0, 4, and this point is 0, 0, it should make sense that this is 4 units apart. So I'm going to use the formula a squared equals b squared plus c squared. A squared is 324 equals b squared. If c is 4, square that to get 16. Subtract 16 to get 308. And I put 308 right here. And now to match the back of the book, x minus 0 is just x, and so I make it x squared. And there's how you find the equation of that one.